Let's look at thread from very high level. A thread in .NET represents a lightweight, independent path of execution within a process. The .NET allows multiple threads to run concurrently, enabling parallelism and responsiveness in the application. Here in the slide, you can see we are initializing a thread instance and passing a delegate, which just prints running a separate thread. This initializes a thread with and it knows which method basically to a pointer to a delegate means a pointer to a method to run execute when thread starts. And here thread dot start, the execution happens parallelly in another thread. It has its own call stack. Pros and cons of threads. Threads has a lot of methods and properties like thread dot start, thread dot join, thread dot abort, etc. compared to thread pools. But it has a overhead. Like when we create instance of thread, it takes about 1 MB of memory. Let's look at the thread example in Visual Studio. I'm creating a console application named thread concept. This will be available in GitHub. So this is boilerplate code hello world from console application. We'll remove this. We'll add a method named boiling water. Here we simply will keep this as static. Here we'll print boiling water task, boiling water, and we'll call this method. Before we jump into task, let's look at Visual Studio Windows and try to understand. So if I run this application, I just see boiling water and the application will finish. But I wanted to show you the window threads windows and the call stack. So if this is thread window, if you don't know how to open this, I close. You have to go to debug, Windows, threads. So you can see we are on this. There is a yellow cursor over here. We are currently on boiling water method, and if you see the call stack, the it starts with main and ends with boiling water. So if you have another task like opening the door, I'll create another method, open door, open door, and I will call this method after boiling water, after boiling water. So this what will happen now is this will run sequentially. First boiling water will be called and then open door will be opened. So what if we want to do the opening of door parallel to boiling water? So we can create a thread, instance of thread as we discussed earlier. A thread will require a delegate. So we'll call open door and we'll call thread.star instead of calling open door directly, we'll call thread.start. So if I run this application now, we still see boiling water and open door, but difference would be can be visually seen in the call stack. If we check the call stack, the current call stack is on pointing to a worker thread with no name, and the call stack directly starts with open door. So what is happening? This thread executes, boiling water is published, and thread.start executes opening door in another call stack. So if we check the call stack of boiling water, we still see it is in the main thread, the yellow cursor. And if you check the call stack, it starts with main and boiling water. So boiling water has a different call stack compared to open door. But here if you see, we didn't had any name of the thread assigned in the call stack in the threads, and it is not advisable for from debugging perspective. We can set the name using .name property. We'll set it as worker1. Let's check the call stack again for open door. See, here the current call stack is open door and the thread name is worker1. So what if what will happen if I call thread.start before boiling water? Pause the video and think. I'll run the application now. It comes as open door, boiling water, open door. So if you saw, it is not fixed. It can execute boiling water or open door or open door or boiling water because it's running in parallel. Any one of this console.write line can be printed first. So let's do one thing. Let's now keep time. We'll slow down this thread. Thread.sleep slows down, basically pauses the current thread. So in this case, the current thread is worker1. So it will slow down the worker1 thread. So what will happen? Pause the video and think what will happen. I'm running the application. The boiling water will be published first. We'll wait for 5 seconds and then open door will happen. So what if you want to wait for like that, if you want to wait for boiling the water before we open the door, we can call thread dot join. This will ensure that opening the door, we will wait for 5 seconds, opening, we'll open the door and then we will boil the water. Let's check this. We are waiting for 5 seconds, nothing is printed on the screen, and then suddenly open door, boiling water happens. So there is one thing you had to, two things I wanted to share. You cannot set the thread dot name twice. If I do it, suppose if I set it to worker2, we'll get an exception for same thread, I mean. Let's look at Threadpool. A Threadpool was created to solve issues related to creation or the overhead of threads while creation and while uh, uh, disposing threads. So thread pool is a concept like imagine you have a pipe which has three slots for threads, and these three threads are free. If you want a task to be completed using this one of this thread, you can request thread pool to you queue your process using threadpool.queueWorker item. So first task is assigned, the first thread will be used. Second task will be assigned, second thread will be used from the thread pool. And third task will be, third thread will be used. And in meanwhile, we queue one more item, fourth item in the thread pool. There are no the maximum for our simplification. The maximum threads which thread pool can have is three, suppose. So it will wait for threads to complete its task. Once the first thread completes its task, it comes back to the thread pool and it is available for next operation. The fourth task will pick up the first thread which has returned back after being free. So here what is happening, the .NET runtime is managing the life cycle of threads. Threads are not created on fly every time. It is basically, if thread is freely available, the threads are reused. So this solves the problem of memory pressure when threads are required a lot in the application. So the key characteristics are, it is managed by runtime. You don't need to create or destroy threads manually. Reuses thread. It reuses thread to avoid overhead, frequent creation and destruction. Limits the number of concurrent thread. Prevents system overload by restricting the number of active threads. Efficient for short-lived operation, ideally for IO bound or short running tasks. So thread pool looks like this. Thread pool queue user work item state, and we pass a lambda delegate, and print, we are just printing here running in thread pool. We'll deep dive into this in code in some time. So there would be a lot of questions which may arise in your head, like how many threads are there at max in the thread pool in a given time in C sharp. So there is a method threadpool.get max thread. This, if we run, we get roughly around, mostly it is around 32,000 plus threads are available for maximum available. You can set it as well using set max thread, but it is not advisable to do so. So another question would be, how many threads are pre-created by default with for a process from minimum perspective. So that is dependent on number of processes cores you have, and that can be fetched from using get mean thread and set using set mean thread step. Like we'll come to yeah, a real world example. I am sharing my Visual Studio with you. Here we are getting a order, we are saving the order to database, and we are sending an email. So sending email is we should be it should be non-blocking, because it's a confirmation mail, it can happen in parallel. So here if you see closely, we are calling threadpool.queue worker item and calling send email confirmation. So this task is queued to threadpool, and if there is free thread available, that task will be completed as soon as the thread is available for this task. If I run this application, you can see order placed, email will be sent shortly, sending email to. This piece of code is also available in GitHub. You can take a look and debug and try to understand what's going on. But there are cons as well for using threads, like mm, no return value. If you see here, we are calling send email functionality, but if you say there is no return, it is void. There is no return value which we can consume, use, and then basically take some other action. That is not there. No built-in error handling. If exception occurs in threadpool thread, it may go unobserved and crash the process unless handled carefully. No cancellation support. It's just like fire and forget. You can't easily cancel the work once it is queued. No fine grained control. You cannot set thread priorities, thread affinities, or custom scheduling behavior. Limited to short lived tasks. Thread pool designed for fast, short tasks, long running tasks can block the thread pool thread and exhaust available thread. Default debugging and tracing. Since the threads are pooled and reused, stack traces and debugging behavior can be harder to follow. No dependency injection or scope lifetime support. In .NET Core, thread pool threads don't have access to scope service. Using them can lead to service lifetime violations. So these are things which you have to keep in mind while using Threadpool. Its implementation is quite straightforward, fire and forget, but it comes with lot of pros, cons. Majorly, we cannot have control granularity as much we have with using task or thread. Thank you. Let's try to understand task. But before we understand task, we need to understand why task was introduced. We know the threads had problem like they were heavy weight compared to like thread pool. While we're creating a thread instance, it consumes 1 MB of memory and it was resource intensive. And we had to basically do synchronization and all. So we studied about thread pool. It was lightweight usable thread, but it gave very limited flexibility and control. Like we can fire and forget, but we cannot control, we cannot have exception, we cannot have return value and all. So to resolve this issue, task was introduced a layer on upon thread in .NET 4.0. It simplified asynchronous parallel programming by giving provision for async await. We'll come to async await later in the section. And it internally uses thread pool efficiently. So while uh, coding in task, you are basically coding as if you are coding in threads, but you get the uh, features of thread pool internally. It is basically high level abstraction over threads. We will cover like that. It supports advanced features like cancellation, continuation, exception handling, and composability. These sections will be covered in advanced lectures later on. So, from analogy perspective, if you think a thread as a new work, like a thread, while you're creating a new instances, you're creating a new worker every time. A task is like managing group of pre-hired workers via smart manager. Basically, it uses thread pool and task parallel library TPL. So, basic thread versus task comparison. If you see on the left hand side, we used to create new thread instance and pass a lambda expression and start the thread to the task is also similar. We, instead of creating, we run task.run and pass a lambda expression, and here we are just printing running a task. Benefits of task is, as we discussed, task is simpler, runs on thread pool, returns a task object, allowing you to continue with, await the result, handle exception, use cancellation tokens. So here is example of task. We'll come to example in Visual Studio shortly. Here there is a task 1 and task 2. Both are downloading files. Download file is a method which is being called file1.txt and file2.txt. So we get this feature await task when all. So we are basically waiting for both the tasks to finish in parallel. So it will take maximum time. Like if it is taking 1 second, this is 2 second, 2 second. The task when all will be probably slightly greater than 2 second to finish the task. So why task over thread today? It is less error prone. The try catch is simpler to write because of async await usage. and we have cancellation tokens support, so we can cancel the operation gracefully, and it's under our control. Async await creates like usage of async await makes the code more readable. The task is more scalable compared to threads because internally it uses thread pool, and it is less overhead because it is we are not creating new instances every time. We are fetching the task from thread pool, and as I already discussed, it integrates with async await seamlessly, so it is more readable, and it has built-in support for performance optimization and system resource reuse. This is abstracted from us, and that's why it's advisable to use task over thread these days. So we'll look into Visual Studio example. So here if you see, I've created a unoptimized I have written an unoptimized Fibonacci number. So I am here basically trying to compute Fibonacci number for numbers near 40, which approximately takes 2 seconds to 3 seconds to compute. So if we do it sequentially, it takes roughly 8 seconds to compute. And here if you see here, task 1, I have 4 different tasks, and each task is computing same Fibonacci number series, and here we are waiting for all tasks to finish in parallel. So when all this task is finished, this line gets executed, and then we stop the timer and we see the last millisecond. So this is also checked in the GitHub. I'll start the application. So we will check how much time sequentially is taking and how much time parallel operation is taking from the task. I'm running the application. For sequentially, it took around 11.5 seconds, and for parallel, it took less than 5 seconds. 5 seconds. So it is more less than 50. Like we have optimized the running operation. So tasks are basically primarily used for high compute, and if you want to do parallel tasks, here we gain efficiency by using the task in parallel, and we're waiting for all tasks to finish, and then we are updating the last millisecond. So here we save time. Thanks. Hello. I'll explain you the concept of async await using a WinForm application. I'm running the WinForm application. So here we have three buttons, and then we have the rich text box and a progress bar. In WinForm application, there is one UI thread, which UI thread is basically responsible for updating the UI control. So to show you that UI thread is busy, free, I've added a progress bar at the bottom, which keeps on moving from left to right, just indicating that UI thread is functioning. So I have added a button sync fetch, which does basically a synchronous operation, fetches from example.com, and it has a 5-second delay. So if I press this button, so what will happen? The progress bar will stop. As you see here, the progress bar has stopped for 5 seconds because we are fetching the data in UI thread, and after we get the data, we publish it in we bind it in the rich text box and then the UI is responsive. So in this case, the problem is the UI thread is busy waiting for the information to fetch from example.com. So this is not an ideal scenario because there would be a database call which would be of long heavy operation. So we cannot wait, we cannot um, ask UI thread to wait for the underlying resources to respond, because application becomes unresponsive. So the so we came up with new concept, async await. We check the code of async await. If you see the code, we are here the difference is in the method itself. We need to specify async keyword before your return statement, and here we are basically awaiting task.delay, and then here we are awaiting client get string async. So what is happening over here, whenever this runs in UI thread, GTQ thread, this runs also in UI thread. But as we encounter await, so what happens, a state machine, this will come to state machine later in advanced section, where the UI thread, this entire information from where it has to resume later from GTQ thread perspective is stored in the state machine. So what is happening, that the UI thread is free to do some other operation, which like moving the progress bar. So here it is freed up, and the task is taken care by another thread of the task.delay. Similarly, while doing await here get string async from HTTP client, we are basically waiting for content to be fetched from this website, and once the website contents are available, it is we can get that content in this text box. So here what we expect, when we click on this button, the UI will still be performing. You see here progress bar is still moving, and then the data was fetched. So here what was happening, UI thread was freed up from the event which gets the data from the website, and when the data was available, it asks UI thread to basically continue the operation and update the rich text box. Similarly, in task, we also have ability to return a string or any value as such. So here I have added one example, async await return statement. If you see here, the code is simplified. We are downloading content string. The method signature starts with async, and return value is here task string. But basically, it is string which we are more bothered about getting the string value. But here it is task string, because in future, if the task is done, we'll get this value of string value. We'll come to it in some time. So this is also how we can fetch the data. So here if I click on async await return, it quickly returns the value, because there is no 5-second lag here. So basically I wanted to show you that with task we can have return statements as well, which gives us more control. Going to the slides. So this method we were checking at the end, download content string task string. So async keyword tells compiler to enable wait, because from this keyword itself, the method basically we expect at least one await keyword in the method body. So task string is a promise of future string, not a string right now. It may be future string when the operation is completed. Return type is task, not direct value. This method returns immediately with task that's complete later. So inside this method, what is happening? We have gone through this, but just to be sure we understand the concept clearly. The caller calls download content async, gets task string immediately. So when it comes reaches here, the caller gets task string this operation, and here we have await. We await for this task string because string is not yet fetched. As soon as we get a response here, like we're pausing at wait. As soon as we get response, resumes when download finishes, returns the final string to the completed string. So main idea behind this is when you have to contact HTTP client or file IO operations, which basically you fire and then later you get a response. You don't want your waiting thread to be waiting for that operation to be complete. You want it to be free so that it can be utilized for some other operation. We use async await. Async await is used for those operation where we basically we don't keep the thread waiting. We basically reuse the thread, and it makes the application responsive, and threads are used more efficiently. So coming to this, return content is not return a string. Return content completes the task string with actual result. Control goes back to the caller after await completes. Caller uses await to unwrap the final result. So in this case it was task string. So real life analogy, baking analogy, if we take, you order a cake, you get a buzzer task. A buzzer rings when cake is ready. You eat cake, you eat cake. Awaits get the string. The task string is like a buzzer that goes off when your data string is ready. Thanks. So we studied about threadpool, task, async, and await. But we need to have clarity in mind when to use which threading mechanism. So we use thread if this long running task and dedicated threads, and we want more control, precise control. That time we use task, but and we use thread pool when we want to just fire and forget. We don't want a return value and all. Then we use thread pool. Usually we end up these days in .NET framework using task and async and await. Tasks are for parallelism, like if you have heavy compute codes, like we shared example where a Fibonacci number is being computed, and if you want to compute in different cores parallelly, then we use task, and it has better exception handling compared to thread because it supports async await mechanism. Async await purely should be used from IO operation because your threads are much efficiently used. Like if your thread is not, the waiting thread is not being used, it is returns to thread pool immediately, or it is available for other task if running. So this is what, if you remember, you will have more uh, better written code in .NET with, and we will write code efficiently. So this mantra, like threads for long running, more control, thread pool for fire and forget, task for parallelism, async await for IO operation. This you remember. Very few people know about it and how to control it. A lot of people are using async await without knowing how it internally actually works. We'll go in depth in future classes how async await actually works internally, which will give us more clarity. Thanks. Thank you for watching this video. This video is from a course available in Udemy. The link will be available in description. In this course, we deep dive into .NET threading concepts like introduction, high level threading concepts, fundamentals of thread, when to use tasks, threads, async await, synchronization context, mutex, pin lock, auto reset event, and I have also provided link for GitHub, which is available. So here you can get the PPT as well as the codes which are used. This you can use for freely. Examples, I would encourage you to fork it and play around with it. And PPT, if you see example, I have used analogies to make things much clearer, like auto reset event can be considered as a turnstile, manual reset event can be considered as open gate, semaphore as a printer which is taking only for a few jobs, countdown event like rocket. So things you will remember for long time. The conceptually everything is explained properly. So please, if you have time, check my courses and check GitHub link. Thank you very much. Have a good day.